Antarctica is one of the harshest places on Earth, a frozen wasteland where almost nothing can survive, and yet right now the world's most powerful countries are pouring billions of dollars into getting there. They are not going for sightseeing, and they are not just there to study penguins. They are racing to secure access to something hidden deep beneath the ice, something ancient, mysterious, and potentially worth a staggering amount, something that could shift global power in a huge way. China has already opened its 5th research station in Antarctica, and a 6th is on the way. Russia is quietly conducting surveys across Antarctic waters, mapping areas they have not fully explained to the public. Meanwhile, a major international treaty that has kept Antarctica protected for more than 60 years is approaching a critical review in 2048. What is really buried beneath the ice? Why are global powers moving so aggressively? And what happens when that deadline arrives? If you are hooked by mysteries like this, hit like and subscribe. We cover stories like this every single week. And to understand what is really at stake, we have to go beneath the surface. What is hidden down there will completely change the way you see the bottom of the world. Most people think Antarctica is just a giant frozen wasteland at the edge of the planet. Empty, lifeless, nothing but endless ice. And if that were true, no major country would care about it. But China cares, Russia cares, the United States definitely cares. And the reason is simple. Antarctica is far bigger, richer, and more important than most people realize. This massive continent is the 5th largest on Earth. It is larger than the United States and Mexico combined. Beneath its frozen surface lies about 70% of the world's fresh water, trapped inside an ice sheet so thick it could bury the entire Alps mountain range. On average, the ice is around 2.5 kilometers thick. In some places, it reaches nearly 5 kilometers. Surface temperatures can plunge to minus 90 degrees Celsius, cold enough to freeze exposed skin in less than a minute. Winds can roar past 300 kilometers per hour. During winter, some regions go 4 straight months without seeing a single ray of sunlight. And still, life is everywhere. Not just penguins and seals on the surface, but organisms living deep beneath the ice in complete darkness. Antarctica may look silent and empty, but underneath that frozen shell, it is hiding far more than most people ever imagined. In water that has not touched the outside atmosphere for millions of years, scientists have found life where no one expected it. Strange organisms are surviving in conditions once thought impossible for anything living. China's researchers have been studying these extreme environments closely, and what they are learning is directly tied to why Antarctica is considered so valuable. Here is what makes the scale of this place so shocking. The ice covering Antarctica is so massive and so heavy that it has actually pushed parts of the continent deep into Earth's crust. In sections of West Antarctica, the bedrock sits more than 2 kilometers below sea level, not because the ocean flooded it, but because the weight of the ice has pressed the land downward like a thumb sinking into soft clay. If all that ice disappeared tomorrow, the continent would slowly rebound and rise over thousands of years. The land still remembers the shape it had before the ice sheet formed. That alone is incredible, but that is only part of the story. The biggest mystery is not the ice you can see or the rock satellites can measure. The real treasure is the information locked inside the ice itself. Layer by layer, year after year, snowfall has built a frozen archive stretching back more than 1 million years. Each layer preserves clues about Earth's past atmosphere, climate, and environmental changes. This ancient record is so valuable that it became one of the key reasons China cited while expanding its presence across Antarctica. That frozen archive is what makes Antarctica truly irreplaceable, and it all begins with something as ordinary as falling snow. A library buried in ice, and the fire beneath it. China's polar scientists did not travel to Antarctica just to build research stations and plant their flag. They came for something far more valuable. Information locked inside the ice itself, data that cannot be found anywhere else on Earth. When snow falls in Antarctica, it usually does not melt. It keeps piling up year after year, century after century, forming an enormous frozen archive. Each new layer presses down on the layers below, slowly compressing soft snow into solid ice. Here is where it gets incredible. As the snow is compressed, tiny pockets of air become trapped inside. These microscopic bubbles act like sealed time capsules. Each one preserves a small sample of the atmosphere from the exact period when that snow originally fell. Scientists drill deep into the ice and extract long cylinders known as ice cores. The deeper they drill, the farther back in time they can go. Some of the oldest continuous ice cores have been recovered from nearly 3 kilometers below the surface. The air sealed inside parts of those cores is around 1.2 million years old. That means researchers can analyze air from a time long before modern human civilization existed. Inside those bubbles, they find ancient carbon dioxide levels, methane concentrations, traces of volcanic ash from eruptions that happened before recorded history, and temperature clues that reveal how Earth's climate changed over hundreds of thousands of years. This is how scientists discovered that when woolly mammoths roamed across Europe, atmospheric carbon dioxide levels were roughly half of what they are today. Antarctica is not just a frozen continent, it is one of the most extraordinary scientific records on the planet. This is how scientists know the Sahara was once a green, wet, and heavily vegetated landscape before it transformed into the desert we know today. Antarctica captured that entire story in silence, layer by layer inside the ice. Think of Antarctica as the world's most detailed diary. Every year adds another page, creating a record that stretches back more than 1,000,000 years. China is drilling deeper into this frozen diary than most countries have ever attempted. These ice core projects are producing valuable data about ancient climates, carbon cycles, and atmospheric conditions. That information helps scientists better understand how Earth changed over time and can improve large-scale models used to study where oil, gas, and mineral deposits may have formed millions of years ago. Here is the alarming part for the rest of the world. If global temperatures continue rising and large portions of the ice melt, this one-of-a-kind record could be damaged forever. There is no backup copy anywhere on Earth. The countries that study the most of it first may gain a major scientific and strategic advantage. But as remarkable as the ice archive is, an even stranger story lies far below. Most people imagine solid frozen rock beneath Antarctica. In reality, parts of West Antarctica sit above dozens of active volcanoes. They do not usually erupt through the thick ice above because the enormous weight of the ice suppresses that activity. Instead, geothermal heat builds underneath, melting the ice from below and creating hidden chambers of water and steam in total darkness. This underground heat is one reason some parts of West Antarctica are losing ice much faster than early models predicted. Scientists initially focused on warming air and ocean temperatures, but they later realized the ice was also being weakened from beneath. One volcano, Mount Erebus, rises above the ice near the coast. It is the southernmost active volcano on Earth. Warm gases from its vents carve caves inside nearby ice. In those caves, scientists have found mosses, algae, and DNA sequences that do not match any currently identified species. Antarctica is keeping secrets in places almost no one can reach. Life forms never before cataloged, surviving in a warm hidden pocket inside one of the coldest places on Earth. It sounds like science fiction, but scientists working near Mount Erebus have found evidence of organisms thriving in places almost no one expected. Mount Erebus also carries a much more human story. In 1979, Air New Zealand Flight 901 crashed into the slopes of the mountain, and all 257 people on board lost their lives. The conditions were extremely harsh, and the glacier has been constantly shifting ever since. Because of that, a complete recovery was never possible. Parts of the aircraft and potentially some remains are still believed to be preserved deep within the ice today, frozen in place nearly 50 years later. Antarctica preserves almost everything: ancient air, ancient rock, and even traces of modern history. But the heat from Antarctica's buried volcanoes does something even more important. It melts the ice from below, and that meltwater does not vanish. It flows into one of the most astonishing hidden systems on the planet, a system that may help explain why China, Russia, and other major powers are investing so heavily in mapping the continent's geology. Rivers in the dark. Travel more than a kilometer beneath Antarctica's surface, and you reach the boundary where ice meets rock. Most people imagine this zone as completely frozen and motionless. In reality, water is moving through it constantly. Beneath the continent lies a vast network of underground rivers and lakes spread across Antarctica and isolated from the outside world for millions of years. These waterways flow in total darkness under immense pressure, untouched by the sky above. Some of these hidden lakes are enormous. Lake Vostok, buried beneath East Antarctica, stretches roughly 240 kilometers long and 50 kilometers wide. It is one of the largest subglacial lakes on Earth, concealed beneath kilometers of solid ice and still holding secrets scientists are only beginning to uncover. That is larger than the entire country of Belgium, and it has remained sealed beneath Antarctica's ice for an estimated 15 to 25 million years. No sunlight has ever reached it. No outside air has touched it. This hidden lake has existed in complete darkness under crushing pressure for far longer than humans have been on Earth. And Lake Vostok is not the only one. Scientists have identified nearly 700 subglacial lakes scattered across Antarctica. Some are linked by underground rivers that snake through cracks and channels in the bedrock. What happens inside these hidden systems is one of the most dramatic processes on the planet, unfolding entirely out of sight. Water slowly fills one lake until pressure builds to a breaking point. Then, without warning, enormous volumes of water surge into neighboring channels, racing hundreds of kilometers underground in just a matter of days. Billions of liters of water move through the darkness beneath kilometers of solid ice and rock. When these floods occur, the ice sheet above actually shifts. Satellites have recorded parts of Antarctica's surface rising and sinking by several meters as pressure changes below. The ground beneath the continent is far more dynamic than most people realize, and here's what makes this even more astonishing. Humans have directly reached only a tiny fraction of the land beneath Antarctica's ice. If you combined every spot where people have physically touched that buried ground, the total area would be about the size of a basketball court. China is paying close attention to this gap in knowledge. That is one reason it has invested heavily in electromagnetic survey technology. These systems send signals through kilometers of ice and rock, revealing what is frozen, what is liquid, and where water is actively moving. By mapping these underground rivers and lakes, scientists can identify where heat is concentrated and where mineral-rich fluids may have accumulated over millions of years. In other words, Antarctica's hidden waterways may also point to some of its most valuable secrets. It looks like scientific research on the surface, but it also provides a detailed picture of Antarctica's hidden geology. And sometimes this underground world reveals itself without any advanced technology at all. In a remote valley in East Antarctica, a deep red liquid flows from the base of Taylor Glacier, staining the ice in a way that looks almost unreal. Scientists call it blood falls. When explorers first saw it in 1911, they were stunned. No one could explain the color. Some thought it might be algae, but algae needs sunlight, and this water was emerging from deep within solid ice. The real explanation is even more fascinating. Blood Falls is made of ancient brine, water more than twice as salty as the ocean. That extreme salt concentration keeps it liquid even at temperatures around -5°C. The water is believed to have been isolated beneath roughly 400 meters of ice for millions of years. When the brine reaches the open air, dissolved iron reacts with oxygen and turns a vivid red almost instantly. It looks like blood, but it is actually a chemical signal from a hidden environment that has been operating beneath Antarctica for ages. This water carries iron and other nutrients from deep in the bedrock toward the sea. Geological teams, including those from China, study these chemical patterns because iron-rich zones can point to regions where valuable mineral deposits may have formed over long periods of time. And the story does not stop underground. When nutrient-rich water reaches the Southern Ocean, it helps support massive blooms of microscopic plant life. These tiny organisms are the foundation of the Antarctic food web. Those blooms feed krill, small shrimp-like animals that gather in extraordinary numbers. Krill in turn sustain blue whales, the largest animals ever known to live on Earth. During the 20th century, more than 360,000 blue whales were killed in Antarctic waters over several decades. Their numbers fell by about 97%. Some populations are slowly recovering, but their future still depends on the health of an ecosystem that begins far beneath the Antarctic ice. From the bedrock through hidden rivers into the Southern Ocean and up the food chain to the largest creatures alive, Antarctica is one vast connected system. And that system may be far more important to the world than most people realize. Pull one thread and the entire Antarctic system reacts. But to understand what countries are positioning themselves to access, we have to go all the way down to the bedrock, because beneath the ice is not just ordinary rock, it is one of the most geologically rich and least explored regions on Earth, and that is a major reason China's expansion in Antarctica has become so focused and so persistent. The continent nobody has ever seen. Scientists have built an extraordinary digital map known as BedMap 2. Using millions of satellite, radar, and aerial measurements, it reveals what Antarctica would look like if every layer of ice vanished in an instant. What appears is not a flat sheet of frozen land, it is an entirely different world. A hidden landscape of mountain ranges, deep canyons, ancient valleys, and structures that no human eye has ever seen directly. For geologists and governments, this is the kind of discovery that demands attention. Buried in the center of East Antarctica are the Gamburtsev Mountains. Their peaks rise thousands of meters above the surrounding terrain, yet they remain locked beneath kilometers of ice. No explorer has ever stood on these summits. No camera has ever photographed them. Their existence is known only through signals sent through the ice and reflected back to researchers. These mountains have not seen sunlight in millions of years. Nearby lies Denman Canyon, a massive trench that descends more than 3.5 kilometers below sea level. That makes it the deepest known land canyon on Earth, far deeper than the Grand Canyon, and it remains completely hidden unless the ice is removed in a computer model. Ancient river valleys weave between these buried mountains, preserved almost exactly as they were tens of millions of years ago, before Antarctica froze over. In some rocks, scientists have found fossil pollen and traces of ancient root systems. They are reminders of a time when Antarctica was a warm, green, and heavily vegetated part of the supercontinent Gondwana. The trees are long gone, but their fingerprints are still pressed into the rock. Fossil pollen, ancient roots, and preserved impressions reveal that Antarctica was once covered in forests long before it became a frozen wilderness. And then there is one of the strangest structures hidden anywhere on Earth. Beneath the ice in East Antarctica lies a massive circular feature nearly 300 kilometers wide. It creates a gravitational signal so strong that satellites can detect it from space. Scientists are still debating what it actually is. One major theory says it may be the scar from one of the largest asteroid or comet impacts in Earth's history. Another theory suggests it formed through powerful geological processes deep within the crust. No one has drilled directly into it. No one has seen it with their own eyes. Yet whatever it is, the structure is larger than many countries and has remained buried and untouched since long before humans existed. Now here is where the story becomes geopolitically explosive. China has been building stations, conducting surveys, and expanding its polar logistics at a pace that stands out in the history of Antarctic research. The reason is tied to Antarctica's ancient geology. Hundreds of millions of years ago, Antarctica was connected to South America, Africa, India, and Australia as part of the supercontinent Gondwana. Those continents now contain major deposits of coal, oil, iron, copper, gold, and rare earth minerals, materials that are essential to modern technology and industry. Rare earth elements are especially important. They are used in electric vehicles, smartphones, advanced defense systems, and renewable energy equipment across the globe. China currently accounts for roughly 60% of global rare earth production and an even larger share of processing capacity. That dominant position makes any region with similar geological potential a subject of intense scientific and strategic interest. Understanding Antarctica's geology, identifying where major deposits may be located, and being positioned to access them if international rules ever change is more than an economic opportunity. It is a form of strategic leverage that could influence global power for decades to come. Survey data and geological models suggest there may be significant oil and gas resources beneath Antarctic waters, along with mineral-rich zones on the continent itself that some analysts believe could be worth enormous sums. And right now, in 2026, none of it can be commercially extracted. Every bit of it is protected by international law. But that protection is not guaranteed forever, and the countdown to a critical milestone is already underway. The race before the deadline. In 1959, 12 nations signed the Antarctic Treaty, declaring the continent a place dedicated to peace and scientific research. The treaty prohibited military activity and set aside competing territorial claims that had been building for decades. And then, in 1991, the Protocol on Environmental Protection added a specific ban on mining and mineral resource activities. For decades, this framework has kept Antarctica off limits to commercial extraction. But there is a clause that few people talk about, that beginning in 2048, treaty parties can request a formal review of the mining ban. That does not mean mining will automatically be allowed. Any change would require broad international agreement and significant legal and political support. Still, 2048 is the first point at which the current prohibition could be reconsidered. That may sound far away, but in Antarctica, 22 years is not much time at all. Building year-round stations, airfields, supply chains, and long-term scientific programs in one of the harshest environments on Earth takes decades. Maintaining a continuous presence can strengthen a country's influence and expertise within treaty discussions, and conducting the geological surveys needed to understand what lies beneath the ice requires years of patient, methodical work. That is why several major nations, including China, Russia, the United States, and others, are expanding research and logistics efforts now. The groundwork for any future debate is already being laid from multiple directions at once. China opened Xinling Station, its fifth Antarctic research base. in February 2024. The station was completed faster than many observers expected and was designed for a year-round operation in some of the harshest conditions on Earth, and China is not stopping there. A sixth station is already being planned at Cox Point. Each new station expands China's ability to operate across a wider portion of the continent, collect more scientific data, and maintain a continuous presence during the brutal Antarctic winter when many other countries scale back their activities. China has also invested heavily in polar icebreakers, aerial survey systems, and deep ice mapping technology. These tools support scientific research, but they also dramatically increase the country's ability to understand Antarctica's geology and environmental systems in far greater detail. And the placement of these stations is especially striking. They are spread across different regions rather than clustered in one area. That approach maximizes geographic coverage and strengthens China's long-term operational footprint across the continent. Russia is moving aggressively as well. It has carried out extensive seismic surveys in Antarctic waters using techniques similar to those employed by the oil and gas industry to map underground structures. Russia also maintains historical territorial claims in Antarctica. Those claims are currently suspended under the Antarctic Treaty, but they have never been formally abandoned. Much of Russia's survey work has taken place in areas where those historic claims overlap with regions believed to have significant geological potential. The United States still operates McMurdo Station, the largest research facility in Antarctica, and it has built a substantial infrastructure network over many decades, but parts of the US Antarctic program have faced aging facilities and budget pressures that have slowed modernization efforts. As China and Russia continue expanding their capabilities, the pace of their investment is drawing increasing attention from analysts who follow polar geopolitics. The balance of influence in Antarctica is shifting, and the countries building the strongest presence today may have the greatest voice if the rules are ever reconsidered. Here's the principle that makes all of this so important. Under international law and diplomacy, sustained presence matters. Countries that operate continuously in a region, build infrastructure, collect data, and demonstrate they can work there at scale often carry more influence in future negotiations than nations that arrive later. In Antarctica, every new station, airfield, and research program can strengthen a country's long-term position. Each new base is a quiet but significant move in a strategic game that may not reach a critical turning point until 2048. And by the time that moment arrives, the key players may already be firmly established. It is important to be precise here. The Antarctic Treaty does not expire. However, beginning in 2048, parties to the Environmental Protocol can request a review of the current ban on mining. That review process could reopen major debates about the continent's future. If a country has spent decades building the most extensive presence on a continent that may contain vast, untapped resources, it enters those discussions from a very different position than a country with little on-the-ground capability. But the stakes go far beyond oil, gas, and minerals. What makes Antarctica truly priceless is everything else that depends on it remaining protected, and the consequences of getting this wrong could be enormous. What happens if we get this wrong? Step back from the research stations, seismic surveys, and treaty deadlines, and look at what is really at risk. Antarctic ice cores preserve a continuous atmospheric record stretching back roughly 1.2 million years. There is nothing else like it anywhere on Earth. If large portions of this archive are lost through melting, or if key areas are disrupted before they can be fully studied, information about Earth's climate history could disappear permanently. That would mean losing scientific clues to questions researchers have not even thought to ask yet. China's own climate models rely heavily on Antarctic ice core data. That is one reason Chinese scientists are drilling deeper than many others. They understand just how much could be lost if this frozen archive is damaged, and the ice is only part of the story. Subglacial lakes such as Lake Vostok have evolved in complete isolation for tens of millions of years. These environments may contain unique forms of microbial life and could help scientists understand how life survives in extreme conditions. In other words, Antarctica is not just a potential source of natural resources, it is one of humanity's most valuable scientific laboratories, a global climate regulator, and a repository of information unlike anything else on the planet. What is decided over the next few decades may determine whether Antarctica remains a protected world of discovery or becomes the center of one of the most consequential geopolitical debates of the century. The microbes living in Antarctica's hidden lakes have been isolated from the surface world for longer than humans have existed. Scientists believe these organisms may contain biological adaptations and chemical processes that are completely new to science, and the implications go far beyond Antarctica. These subglacial lakes are among the closest natural comparisons on Earth to places like Europa, one of Jupiter's moons, where a vast ocean may exist beneath a thick shell of ice. If life can survive in Lake Vostok under crushing pressure, complete darkness, and extreme isolation, it could reshape how scientists think about life elsewhere in the universe. But there is a catch. If these sealed environments are contaminated, the scientific opportunity could be lost forever. China has been one of the leading countries proposing strict protocols for accessing subglacial lakes without introducing outside contamination. That reflects how valuable these environments are to the global scientific community, even as geopolitical competition in Antarctica grows more intense. The underground drainage system beneath Antarctica is also essential to life in the Southern Ocean. Iron and nutrients carried from deep beneath the ice, including systems like the one feeding bloodfalls, help support vast blooms of phytoplankton. These microscopic organisms fuel the Antarctic food web. Phytoplankton feed krill. Krill support whales, seals, penguins, and countless seabirds. Blue whales, which are slowly recovering after severe population declines in the 20th century, depend heavily on healthy krill populations. Any large-scale disruption to this nutrient cycle could ripple through one of the most productive marine ecosystems on Earth. And then there is the ice itself. Antarctica stores enough frozen water that if it were all to melt over very long timescales, global sea levels could rise by roughly 60 meters. Every coastal region on Earth would be profoundly affected. That is an extreme scenario that would unfold over centuries to millennia, not overnight. But parts of West Antarctica alone contain enough ice to raise sea levels by several meters, and some areas are already changing faster than scientists once expected. What happens in Antarctica does not stay in Antarctica. The consequences could reach every shoreline on the planet. Adding industrial activity to an ice sheet that is already under stress could place even more pressure on a system with less resilience than many people realize. The Antarctic Treaty has held for more than 60 years because the countries involved concluded that cooperation served them better than competition. That cooperation made possible the ice cores, the discoveries in subglacial lakes, the satellite maps, and the climate models that scientists around the world rely on today. And 2048 does not have to become a breaking point. Several treaty members have publicly supported strengthening long-term protections for Antarctica, including maintaining the ban on mining. The legal framework to keep the continent protected already exists. The real question is whether nations that could benefit economically from future extraction will choose to preserve Antarctica's scientific and environmental value instead. And that choice is not waiting until 2048. It is being shaped right now by where countries are building stations, how they are expanding their logistics networks, and how strongly the international community decides that some places are too valuable to disturb. Antarctica is one of the few places left on Earth that remains so important precisely because it has largely been left untouched. The ice cores exist because snowfall accumulated undisturbed for more than 1 million years. Subglacial lakes preserve ancient ecosystems because they have remained isolated. The Southern Ocean food web thrives because the nutrient cycles beneath the continent have operated for millions of years without major disruption. 22 years may sound like a long time, but in Antarctica it is not much time at all. The strategic race is already underway, and the most consequential continent on Earth may be the one most people rarely think about. If this changed the way you see Antarctica, hit like and subscribe so you do not miss our next deep dive. Turn on notifications so you stay ahead of the stories shaping the future. Now I want to hear what you think in the comments. If 2048 arrives and pressure to reconsider the mining ban becomes intense, do you believe the treaty will hold, or will the countries with the strongest presence carry the greatest influence? And if you want to keep following this story, the next video explores another frontier facing enormous pressure right now. What is happening there is just as important.